One more problem on sketching the discrete time signal based on the basic operations. Here question is x of n is equal to 1 from minus 1 to plus 3 and 1 by 2 and n is 4, 0 elsewhere. I should sketch these two, 2 into x2 of n, and second problem is 1 by 2 into x of n plus 1 by 2 into minus 1 whole to the power of n into x of n. First I should sketch this signal, that is x of n is given that its value is 1 from minus 1 to this is minus 1, its value is 1. At 0 also its value is 1. At 1 its value is 1. At 2 its value is 1. At 3 its value is 1. 0, 1, 2, 3, this value is 1. At n is equal to 4, this value is plus 1 by 2. That is plus 1 by 2. Okay, this is the given signal x of n. Okay, next in this first problem, that is 2 into x2 of n they given. That means first I should scale it by 2, then go for the amplitude scaling. That is amplitude scaling value is 2. That is first I should get x2 of n. x of 2n. x of 2n means here is scaling factor is 2. That means signal will be compressed. How the signal will be compressed? That is, I should multiply all these by, since scaling factor is greater than 1, the signal will be compressed. That's why divide the time axis by 2, and we should know that discrete time signal exists only at the regular time intervals 0, plus 1, minus 1, plus 2, minus 2, like that. Okay. Now suppose if I take x of 2n, this is x of n. I'll take one intermediate signal v of n is equal to x of 2n. At what value of n I'll get minus 1 here when n is equal to minus 1 by 2. That is, when n is equal to minus 1 by 2 and n is equal to minus 1 by 2, you get v of minus 1 by 2 is equal to x of minus 1. 0 by it will be 0 only. This will get at 1 by 2, this I will get 1, this I will get 3 by 2, this I will get 2. That is, when n is equal to 0, it will be v of 0 is equal to x of 0. N is equal to 1 by 2, v of 1 by 2 is equal to x of 1, and n is equal to 1, v of 1 is equal to x of 2, and n is equal to 3 by 2. We'll get v of 3 by 2 is equal to x of 3, and n is equal to 2. I will get, that is, v of 2 is equal to x of 4. See, this you cannot map it because x of minus 1 comes at v of minus 1 by 2. At minus 1 by 2, since this is a point, it is a decimal point, discrete time signal does not exist. This can be mapped. X of 0 is mapped at v of 0. X of 1 cannot be mapped because x of 1 should map at 1 by 2. 1 by 2 is not an integer. That's why we cannot map here. This can be mapped by x of 2 can be mapped at 1. X of 3 also you cannot map it because it's 3 by 2 is 1.5, and x of 4 can be mapped at 2. That means what is there at x of 0 comes at 0 in the new signal. What is there at 2, it comes at 1. What is there at 4, it comes. Remaining samples will not exist in the scaled version of a signal. That is, this is the v of n. Okay, this is the n. X of 0, what is the x of 0 value is 1, it comes at v of 0. X of 2, it comes at 1, that is its value is 1. Next, x of 4 value is v of 2, that is x of 4 value is 1 by 2, that is it comes at 2. See, this is the scaled version of the discrete time signal. Next is, I should go for amplitude scaling. This whole signal I should multiply it by 2, that is 1, it will become, multiply this amplitude by 2, this is 2, this is also 2, and this 1 by 2 into 2 will become 1. 0, 1, 2. This gives the 2 into x2 of n. Okay. Next to have that is this problem, that is 1 by 2 into x of n plus 1 by 2 into minus 1 whole to the power of n into x of n. That is, second problem here is 1 by 2 into x of n plus 1 by 2 into minus 1 whole to the power of n into x of n. We know that x of n signal, it exists from minus 1 to plus 4, minus 1 to minus 1, 0, 1, 2, 3, 4. This is the n. This value is 1 by 2. These values are 1. This is the x of n. Let us take this is one part and this is another part. First, let us get the 1 by 2 into x of n. Here we don't need to do any scaling, only we should go for the amplitude scaling. That means this is divided by 2. That means I'll get, that is, I'll take this as an x1 of n. I'll take this signal as an x2 of n. Then we'll go for the addition of x1 of n plus x2 of n. To get x1 of n, same signal we'll get. Only thing is amplitude is divided by 2. Minus 1, 0, 1, 2, 3. This is 4. This is n. That is x1 of n is equal to 1 by 2 into x of n. Amplitude is 1. When it is divided by 2, it will become 1 by 2. 1 by 2 when it divided by 2, it will become 1 by 4. This is the first part of the signal. Second part of the signal is same x of n, I should multiply it by minus 1 whole to the power of n. Then I should divide this by 2. First I will multiply it by minus 1 whole to the power of n. That is, when n is 0, here x of n value is plus 1. Minus 1 whole to the power of 0 value is 1. You will get the same signal, that is, at minus 1 its value is 1. So when n is 0, its value is same, you get 1. When n is minus 1, this value is 1, but minus 1 whole to the power of n. That is minus 1 whole to the power of n value is, when n is 1, it will become minus 1. Minus 1 into plus 1, it will become minus 1. You'll get this is minus 1. When n is 1, again we'll get minus sign here. Again we'll get minus sign, that is, it will become minus 1. Minus 1. When n is 2, it will become plus 1. You get same signal. When n is 2, its value is 1. When n is 3, for odd number, it will become negative sign. You get minus 1. When n is 4, it will become plus 1 here. That is, its value is 1 by 2 here. Okay. This is n. This is minus 1. This is 0. This is 2. This is 3. This is 4. Once again, I'll repeat this problem. Here I am writing the minus 1 whole to the power of n into x of n. When n is minus 1, when n is minus 1, x of minus 1 value is plus 1. And minus 1 whole to the power of minus 1, that is minus 1 whole to the power of minus 1 value is 1 divided by minus 1. It will become minus sign. That's why this amplitude is multiplied by negative sign. It will become minus 1. When n is 0, minus 1 whole to the power of 0 value is 1. 1 into x of 0 value is 1. 1 into 1, it will become 1. When n is plus 1, x of 1 value is 1. And minus 1 whole to the power of 1 value, it will become minus sign. That's why I'll get minus 1. When n is 2, minus 1 whole to the power of 2 value will become minus 1 whole to the power of 2 value will become plus 1. Then it will become plus 1 into x of 2 value is 1. That will get 1 as it is. When n is 3, minus 1 whole to the power of 3, it will become minus 1. Minus 1 into x of 3 value is 1. It will become minus 1 again. When n is 4, minus 1 whole to the power of 4 value is plus 1. That is multiplied by x of 4 value. X of 4 value is 1 by 2. 1 by 2 into 1, it will become 1 by 2. And this whole signal is divided by that is same signal I'll get, that is with the change in amplitude. This is -1, this one, this is 1 by 2 into -1 whole to the power of n into x of n. -1, that will become minus 1 by 2. This will become plus 1 by 2. This 1 by 2 divided by 2 will become 1 by 4. Now I should add this plus this one, that is x1 of n plus x2 of n. This is nothing but x2 of n. Okay, when I add these two, you'll get at -1, this value is plus 1 by 2, this value is minus 1 by 2, it will become 0. Okay, at -1. At 0, this value is plus 1 by 2, this value is also plus 1 by 2, it will become plus 1 by 2 plus 1 by 2, it will become 1. Okay, next at 1, this value is 1 by 2, this value is minus 1 by 2, it will become 0. At 2, this is 1 by 2, this is also 1 by 2, this will become 1. Okay, at 0, 1, 2. At 3, this is plus 1 by 2, this is minus 1 by 2, it will become 0. At 4, at 3 it is 0. At 4, this is 1 by 4 and this is also 1 by 4, it will become 1 by 2. Okay, this is the final answer. This is x of n. Okay, you can take this is equal to, sorry, y of n I can take. This is the y of n. This completes the problem. Thank you.